Good morning, students. Myself is Srinivas, Assistant Professor, Department of ECE, Kakatiya Institute of Technology and Science, Warangal. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18EC502A. Topic: Supervised Machine Learning Algorithms. Machine learning algorithms are classified into three types: supervised, unsupervised, and reinforcement machine learning algorithms. Supervised machine learning algorithms. The first one is regression, the second classification. Under regression, linear regression, multiple linear regression, polynomial regression. Under classification, logistic regression, k nearest neighbor algorithm, support vector machine, naive Bayes algorithm, decision tree, and random forest. Regarding regression equations, in simple linear regression, the regression equation is y is equal to b naught plus b1x. Dependent variable y, independent variable x. In multiple linear regression, dependent variable is y, independent variables are x1, x2 up to so on xn based on application. In polynomial regression, dependent variable y, independent variables x1, x2 up to so on xn, and the polynomial regression equation is y is equal to b naught plus b1 x1 plus b2 x2 square plus bn xn square. Linear regression. Now here in linear regression, the regression equation is y is equal to b naught plus b1 x. Here x is the independent variable, y is the dependent variable. Now here based on the given data, we have to plot the scatter diagram. We have to plot the scatter diagram, and we need to draw a best fit regression line. And for the new data, we have to predict for the new independent data what is the value of y. That is here age 5, 8, 11, 17. What is the shoe size? 7, 8.25, 9, 9.75. Now here, what is the shoe size of a 10-year-old boy? For that, what we have to do is, we have to draw the scatter diagram, need to draw the best fit regression line. Based on the regression line, we have to predict the dependent variable. In multiple linear regression, y is equal to b naught plus b1 x1 plus b2 x2 plus up to so on bn xn. Here the multiple linear regression depends on n number of independent variables. Here based on these values, we need to predict the value of dependent variable y. Polynomial regression. In polynomial regression, the diagram, the scatter diagram is not linear. Now here, if the scatter diagram is linear, then we can easily predict. We can apply simple linear regression. But in the case the scatter diagram is not linear, that case we need to apply the polynomial regression. The polynomial regression equation is y is equal to b naught plus b1 b1 x1 b2 x2 square plus bn xn square, like that. Next, logistic regression. Logistic regression is useful for classification. Now, in what situation we have to apply logistic regression is when the result is binary, that is 0, 1, yes, no, or true, false. If you need probabilistic results, when you need a linear decision boundary, when you need to understand the impact of a feature, in that situation, we need to apply logistic regression algorithm. Logistic regression algorithm is majorly used for classification problems. Now here, what is a training dataset and a testing dataset? Now here, consider a machine learning model. Consider a machine learning model. Now here we have some data. We have some data. In that, 80% of the data can be used to train the model. 80% of the data can be used to train the model, and the remaining 20% of the data is used to test the model. Based on the machine learning model accuracy, this particular model will be employed. That is, if the accuracy of this particular model is high, then we can deploy this particular machine learning model. If the accuracy is less, then we have to adapt other process. Next, k nearest neighbor, KNN algorithm, k nearest neighbor algorithm. It is a supervised machine learning algorithm that can be used for classification or regression task. It is based on the idea that the observations closest to a given data point are the most similar observations in a data set, and we can therefore classify new data points based on the values of the closest existing points. By choosing k, the user can select the number of nearby observations to use in the algorithm. Just make a glance algorithm steps. Now here, one example with KNN algorithm, football, basketball, tennis ball, their cost and their durability. Here the scatter diagram is plotted based on their cost and durability. Now here these are the footballs, basketballs and tennis balls. Now here I want to assign this particular data point. I want to assign this particular data point R1 some X ball to which category. Now here k nearest neighbor means if k is equal to 5, for this particular ball we have to select k nearest balls, k nearest neighboring balls. If k is equal to 5 means here I selected k neighboring balls. Now here out of 3 categories, these 3 balls, the more number of balls associated with this particular ball is tennis ball. So this particular ball can be assigned to tennis ball model, like that. Here by selecting the value of k, the closest 5 balls to our new data point. Here there are 3 tennis balls and 1 each of the basketball and football. Thus we will classify the black ball as tennis ball. That is, this particular black ball can be classified as tennis ball. Next, decision tree algorithm. Decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problems. It is a tree-structured classifier where internal nodes represent the features of a dataset, branches represents the decision rules, and each leaf node represents the outcome. In a decision tree, there are 2 nodes, which are the decision nodes and leaf nodes. Decision nodes are used to make any decision and have multiple branches, where leaf nodes are the output of those decisions and do not contain any further branches. Decisions are performed on the basis of features of the given data set. Now, this is the model for decision tree algorithm. Decision node, here this particular decision node can be classified into decision nodes, further decision nodes. The first decision node is called root node, and then the decision node once again can be classified into either leaf node, or leaf node, decision node. Leaf node is the end of a particular part. Model example for decision tree, just to go through. You just make a glance why we use decision tree and decision tree terminologies just now we discussed. Random forest algorithm. Random forest is a popular machine learning algorithm that belongs to the supervised learning technique. It can be used for both classification and regression problems, but mostly useful in classification problems. As the name suggests, random forest is a classifier that contains number of decision trees on various subsets of the given data set and takes the average to improve the predictive accuracy of that particular data set. Instead of relying on the single decision tree, random forest takes the prediction from each tree and based on the majority votes of the predictions, and it predicts the final output. That is, here in random forest algorithm, n number of decision trees are incorporated. Based on the voting, the model prediction will be done. Here once again, two phases are there: training phase and testing phase. In general, training can be done with 80% of the data, and testing can be done with 20% of data, and the machine learning model can be deployed only after getting better accuracy of that particular model. Greater the number of trees in the forest leads to higher accuracy and prevents the problem of overfitting. Now here, the students just go through why we use random forest algorithm, advantages of random forest algorithm, disadvantages of random forest algorithm. Support vector machine algorithm. It is comes under the category of supervised learning, majorly used for classification problems. That is, here some data is given to the support vector machine algorithm. The data can be classified into different classes based on the features present in the data. Now here, this is one of the example of support vector machine. Some data points are given. Let it be some positive data, let it be negative data. Now here we have to classify this data based on the boundary lines. The distance between these two boundary lines is called marginal distance, and this is the center line in between the boundaries is called hyperplane. Here, this particular line is called plane when this particular diagram is 3D. In 2D, we cannot say it is a hyperplane. In two-dimensional case, we call it as a line. In 3D, it is called hyperplane. Hyperplane is also called decision boundary. The distance between two margin lines is called marginal distance. Now here, support vectors. Now here, after drawing some random marginal lines, uh, uh, this particular marginal line pass through these data points. This particular marginal line pass through this particular data points. Here, these data points are called support vectors. Support The data points onto which the margin passes is called support vectors. Here the aim is to maximize the marginal distance. The same data you can observe, the same data can be classified based on marginal distance d1 and d2. Here aim is to maximize the marginal distance or select the hyperplane which has the maximum marginal distance. In the above example, d1 is less than d2. Means here we need to select the hyperplane which has a maximum marginal distance, that is d2. For new test data, the model with d2 distance will give more generalized result when compared to model with d1 distance. Now here, if we observe the two diagrams, uh, as discussed in the previous slide, it is positive data, it is negative data, it is positive data, it is negative, sorry, it is negative data. Now here, uh, for n number of iterations, we have to calculate the marginal distance like d1, d2, d so on dn. The marginal distance, if it is like this, then the marginal distance should be in such a way that the distance between the two lines which is having the highest, that can be considered as the hyperplane. That can be considered as, simply we can say that we need to select the hyperplane which has the maximum marginal distance. Naive algorithm, it is used for classification problems, comes under the category of supervised learning, based on Bayes theorem, probability Bayes theorem. That is here, this can be calculated like this: posterior probability is equal likelihood multiplied by probability divided by the predictor. Just go through the diagram. Based on the data given in table, we have to calculate what is the probability of playing cricket with the following conditions. Here, for n number of conditions, the model is trained with the above data. Then here what we have to do is we need to calculate what is the probability of playing cricket for the given conditions. This can be done with the help of Naive algorithm. Underfit, optimum, overfit. Underfit means high training error, high test error. That is, underfitting is a scenario in data science where a data model is unable to capture the relation between input and output variables accurately, generating a high error rate on both the training and testing sets. Overfitting. Overfitting means low training error, high testing error. Means this is a situation when the training data is corrupted with noise. Thank you. We will meet with the next lecture.